Alright, we're going to start off by doing some review of linear functions. We're going to start off by saying, alright, let's plot the points. A is negative 2, 1, B is 7, 5. Now one thing I'm a stickler on is labeling your scale, and that doesn't just mean label 1, it means label at least every 5. You can label every 2, every 3, every 4, every 5. I do not want to see you label every single one, and we're going to go all the way around. Now I conveniently labeled this thing, or showed the solid a little bit darker lines so it'd be easier for you to follow. So if we go 5 and negative 5, 1, 2, 3. I didn't do it on that one. So we're going to start off with the point A is negative 2, 1. We're starting at our origin. We go 2 left, that's x is negative 2, and up positive 1. And we'll label that as A, and we'll go B is 7, and then up to 5. And now take out your ruler and connect the dots. We plotted the points. How do we find slope? There are a lot of words that go with slope that you are familiar with. The typical one is rise over run. So we can count them in this case. We could say 1, 2, 3, 4. We can 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the most basic that you first learn. How else could we calculate this for? Well, this y value is 5. This y value is 1. So 5 minus 1 would give us our 4. This x value is 7 minus this x value of negative 2. So that gives us 9. Our slope will be 4 divided by 9. It is our, I'll talk about a little bit more in the next one. How about distance? Most of the time when we ask for distance, a lot of students will say, yeah, there's some formula. I don't remember exactly what it is, but I know there's some formula. Well, instead of trying to memorize that formula, another way to do is look and see what shape do you have here. If I put in a little symbol there, you can see that it's a right triangle. What do you know that applies to all right triangles? Let me start off right now to let you know that anytime I'm asking these kind of questions, it's a good thing to hit pause. You think about it for a second and then start it back up. We should be able to remember that for a right triangle we can apply the Pythagorean theorem. So this would be 4 squared plus 9 squared equals the hypotenuse squared, or in other words the square root of this. So we'll have 16 plus 81, 97. Make sure each line is written correctly, that we don't leave off the square root symbol. Now we'd look, can we simplify square root of 97? 97 is a prime number, so no, we can't. Midpoint. What does that sound like? Middle. It's that point that's in the middle. So we're going to look at this line segment and say what point is in the middle. We could say it's going to be somewhere in this vicinity. One way to do it is to say, let's look at just the vertical part here. If we're going to be talking about a point here at 1 and a point 5, what point is exactly in the middle? That midpoint of those two numbers. We can figure it out fairly quickly that it'd be right about here. This is at 3. A way to think about that middle point is the average. The average of two values is that number that's exactly in the middle. So if we just say for the y values, that's the one I'm dealing with there, we would have 1 plus 5 divided by 2. Similarly, if we're going to look at negative 2 and 9, what number is exactly in the middle? What is the average of those two values? Well, again, we're going to add them up and divide by 2. So we'll get 5 halves, comma, this would be 6 over 2 or 3. And that would be our middle point. Now let's take a look at it. If we have here 3 and we come over here at 2.5 and come up, that is our midpoint. It's often given the letter M. In general, slope, we have those words like rise over run. It is the change in y over the change in x. It is the change in the vertical, because we're not always going to be using x and y, over the change in the horizontal. If we have 2 points, x1, y1, and x2, y2, we'll have y2 minus y1 over x2 minus x1, and that's also known as delta y over delta x. You've probably seen the symbol delta in your science classes. It just means change. It's a Greek letter. If we represent that change as being delta y over delta x, we can write the distance as the square root of delta y squared plus delta x squared. Now the one thing I want to point out for that is you can't take our slope values when reduced. You have to take that original change in y over change in x. And then the midpoint would be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And let me erase that parenthesis there. When you are writing a point, make sure that it is written with parentheses on every step. Now note, I could also change this distance 1, going back there for a second, and call it delta x squared plus delta y squared, because you can regroup them, or it's not even regroup, you can commute them, you can move them around.